Sitabra asked me to give some kind of an overview talk, which suits me okay, because I am not great expert in game theory and it is sort of an outsider's view of the subject. I will not get into great details, but give some impressions which need not always be even right. Okay. So, as children we all enjoyed playing games, and even non-human animals are also known to enjoy playing games. I do not know if you can think of any non-human animal playing games. Dogs I know. No, quite honestly, but not so many others, and okay, mostly mammals and so on. You can really, maybe birds also.
Dolphins.
Dolphins, yeah. But dolphins are mammals. Okay. Anyway, so I am saying even that is not so generic. Worms don't play games, but for humans, games, as children, it's an enjoyable activity. We enjoy, and there is some spelling mistake. There are many types of games people play. So there are games of skill, 100-meter dash. 100-meter dash is a very simple game. There are lots of players. They compete against each other, but there is no real competition. Each one plays by itself, and one of them wins. Now it seems somebody will say that we are only interested in games where people have to fight with each other or compete with each other or some such thing. I am pointing out that the word games includes other things which do not involve agents which compete with each other. They are competing, but they are not competing in any, they are not doing any strategical work, they just do as well as you can, and one of them wins. Okay. And these are called games because in Olympics there are races. Okay, very good. So there are games of luck like snakes and ladders we played as children. These also do not involve any strategy. Some dice turns up and people will very happy, somebody wins, somebody loses. But there are games of strategy like tic-tac-toe we start with, and then chess and poker. And these are the ones which there is a mathematical theory about. So the theory of games deals with games of the third type and not games of the first two types. I think there is some probability theory involved in studying in roulette, whether you should bet this or bet that or some such thing, but it is not in the theory of games. So the mathematical theory of games, which started by von Neumann and Morgenstern, deals with this last category and lets you find the best decision in a complicated situation. And it has been applied to many real world situations in markets, war games. That was the thing which actually made it very glamorous, because around 1950 or so, beyond 1950, people in Rand Corporation used to make scenarios of nuclear wars, what will happen if A does this and B does this, that kind of stuff, and very complicated scenarios, and some of these things were developed there. But markets, people are, I have some product, I want to put it into the market, what price shall I put it at? If I put it at too low price, I will not get much. If I put too high price, people will not buy it, and so some complicated analysis is involved, and game theory can help in these kinds of decision makings. Okay. It has been used in these kinds of things. This is not always fully game theory, it is something sometimes called decision theory, but it is part of game theory if you like and need not be the whole part, but maybe it is quite often the real application break down to some such things sometimes.
So Deepak, I just wanted to make a comment that I read once Jacob Bronowski said that when he asked von Neumann that in games as in chess, so von Neumann said chess is not a game. In principle, you can always work out the solution. So for him, game theory only deals with incomplete.
Precisely. No, so I am pointing out that when I say game theory, I am not von Neumann. Von Neumann was dealing with games of a particular type, and the mathematical theory of games only deals with those types of games, but that is not the whole set of games. In fact, for them chess is a trivial game. right? And I know that chess is not trivial as far as I am concerned or some such thing. So, even the mathematical theorems which they give you are not making sense to me as a ordinary citizen. Okay, and you should try to understand the distinction between these two, why is chess a trivial game and why is it not a trivial game. Okay, that is not a paradox, but that is some interesting play on words. Okay. So, in the application of game theory to real life problems, first one has to define the problem precisely. That is already a problem, because the mathematicians do not deal with the subject unless it is very precisely defined. Okay. So, it is not easy to do in many situations. The mathematicians start with this first word is called rational agents. Now, it turns out that it is very hard to find rational agents in real life, and so the theory may say something or the other, but does it apply in real life? It is not always clear that I should even try to apply it. Okay? I am not saying that the theory is useless, I am just saying when you are applying it to a real situation, you have to watch out for all these. So, afterwards people have studied all kinds of stuff, something called bounded rationality, trembling hands, limiting. Bounded rationality means I am a little bit rational, but if you look at a person who is working in the stock market, he has lot of information, but he cannot solve a cubic equation. In fact, if you ask how many of the people who work in the stock market can solve the cubic equation, the answer will be okay 10-15%, but not much more, right. So, it is not as if everybody knows how to solve a cubic equation, but a mathematical game theorist will assume that given a real cubic equation, everybody knows what are the 3 roots, and that is not always a reasonable assumption. Trembling hands means that you actually want something, but when you apply it in real life, you are making some mistakes. There is some error of transmission, you type something, the adjacent key gets pressed or some such thing. Limited computing power says that to get the full solution requires too much work, and I am not able to put in that much work. So, I do not try to find the best solution. So, that answer to the chess problem is this, that we do not have enough computing power to decide if chess is trivial or not trivial, or we know that it has to be trivial, but trivial in which way. Okay. Okay. So, second point is this, that there in the starting theory, which is the best developed, the payoff matrix has to be specified. So, even if the payoff matrix is known to all the agents, the utility value assigned by agents to payoffs may not be known to others. So, I am using the word utility here in some sense, which is slightly different from the sense in which Sushmita used it in the morning. It is like this, that suppose there is a lottery in which I have to pay 1000 rupees, and if I win I get 2 lakh rupees, if I lose everything, and the winning probability is 0.01. Okay. So, 1% probability of winning, but you get 2 lakhs instead of 1. So, the expected value of payoff is quite large and positive. 2 lakhs minus 1, okay, 1, okay. But if you ask people, are you willing to buy this ticket? Large number of them will say no, I do not want to buy, because with a large probability I will lose 1000 rupees. And so, this point is known to everybody, and so then people worried that what is wrong with this, why are people not maximizing their profit or some such thing. So, they said that you will get plus 1 lakh, so plus 1 lakh, 2 lakhs if you are lucky, or you might lose 1000. But for me, loss of 1000 is much more upsetting than possible gain of 1 lakh or 2 lakhs, because the utility value of 2 lakhs is less than the disutility value of what I will lose. Okay. So, you should not maximize the profit, you should maximize the utility of the profit. Okay. So, you know, people often say that okay, you have 1 lakh, 1 crore or 10 crores, what is the additional benefit of the next crore? And so, the utility value of money kind of increases as the log of the money, that is general belief or general based on what people can see. Okay. But then if it depends on the log of the money, then you do not know the utility values. You know the, you know, in the standard setting you know how much somebody will win, but you do not know how much he likes to win that kind of money, and that makes a real difference in real market situations, because you want to know whether he will buy or whether he wants to, you know, he considers that a good thing or bad thing, and it is not the payoffs, but the utility value of the payoffs, and that are usually not known. You can say in principle I will deal with games where everybody's utility value is known. You can deal with such games, but it is not much real life expectation of you. Okay. And then there is this other problem, which is that sometimes I do not even know what I am optimizing. So, I typically go to a market, I want to buy a shirt. This guy shows me several shirts. I know that, you know, I am going to spend about this kind of money, maybe 500 rupees, maybe okay, 2000 rupees is allowed, but not 50,000, some such thing. Okay. But of course, there is a price and there is the you know, style and color and all kinds of stuff are involved. So, sometimes there is a thing which is much better style, but it has a higher price. So, I do not optimize over the price and buy the cheapest shirt, I do not optimize over the style. So, what does the mathematician do? They say make a weighted average of all the different qualities and then maximize that. Okay. So, I can say 0.1 times the utility of price plus 0.9 times the utility of style or whatever. Turns out that when I am actually buying it, I have never decided on these weights. Most people do not decide on these weights and they make a decision. So, I am not, you know, the starting point of the game theory is not working, because I do not have a single valued function I optimize, and I have not decided on that. It is not like other people do not know, even I do not know. So, how do I make my decision? A theory which describes stuff where everybody is optimizing their utility value to the best precision and knows what other people are doing, is a theory which is very caricature and very up in the air. Okay. So, I just wrote this down. So, it's like if you are trying to decide whom you are going to get married to, then the person should be intelligent, he should be rich and all these things. No, most people do not have a precise numerical weightage to these different factors, right. So, how do we decide? These decisions are very important in our life, and unfortunately game theory has nothing to say, and that one should appreciate. Okay. And I made it up for marriage, but you can think of anything else and it will be still very much similar. I want to buy a house, again I do not always know what function I am optimizing. Okay. All right. So, this is the first thing I would like to discuss. I am sure you have had many long hours of lectures, so everybody knows what is the prisoner's dilemma, but let me still introduce it as if you did not know it before. Okay. So, this was introduced by Flood and Drescher in 1950, and some different variants have been studied. But anyway, in the standard setting there are two prisoners, they cannot talk with each other. The police does not, you know, they know that these people did something, but they do not have enough evidence to convict them. So, they offered them a deal. They say you confess and say this other guy also did it, and then I will let you go free. This is plea bargaining, and then the other guy will get strict punishment. And this deal they offered to both of these people, but separately. The two convicts are in separate rooms, they are not allowed to talk to each other. Okay. And it says that each person is selfish and only wants to reduce his own sentence and knows that the other person is also offered the same deal. and they only have 1 day to decide. So, next day, right now you do not have to tell right now, you decide, you apply all your logic and whatever and tell me tomorrow you want to defect or not, that is the game. And these people, this was analyzed by these people. So, here is the payoff matrix, picture is taken from Wikipedia. He says if A stays silent, B stays silent, each of them gets 1 year term -1. If this one is silent and this one testifies, then this gets very stiff sentence, 3 years in jail, and that guy goes free. So, he is happy. This is the opposite, this testifies and this stays silent, then this one gets stiff sentence and this one is free. And if both of them testify, then both of them get -2. Okay, this is very simple, straightforward game. Okay. So, what will the rational agents decide? That was the game, that was the question. And the answer is that there is some complicated argument which was given in these game theory books, which says that the rational thing to do for both prisoners is to testify against each other. Emphasize on the word rational thing to do. This is the argument given in one line. It says this is the best choice A can make, whether B decides to testify or decides to stay silent. Say if he testifies, then what should I do? Okay, I should do this. If he is doing this, then what should I do? I should do this. And it's the same answer. It is that you should defect, and the other one also gets the same thing. And so, both of them make this rational choice, but it is clearly not the best choice. And these are rational people, they are deciding amongst 2 options. And so, what is going on? Why is this obviously counterintuitive result being touted as the rational answer? That is the question in the game theory. Okay. This point of course is well realized. The argument given seems quite convincing. You can go through it 5 times. How can both rational agents decide that it is better for both to testify? That is the paradox. And what is the answer? Since you have all studied this problem already, you should know the answer. It is not clear. It is not clear to many people, or they are not able to convince me of the answer. They can repeat something or the other, but either they do not get convinced themselves, or they are not at least able to convince me that that is the right thing to do. Okay. So, what is it? The resolution of the paradox lies in going beyond each agent, optimizing, assuming that the other person has already made his choice. Okay. And maybe the rational agent should both realize that it is better for both to stay silent. It is not very deep remark I am making here. If they are rational agents, they should decide that it is best for them to both stay silent. I mean, what is the big deal? There is a 4x4 table, you look at what is the best one, and that is the answer. So, this obvious point is made in academic settings, in some game theory discussions. So, people said that yeah, you are right, but this behavior is called super rational, going beyond the rational solution, and of course, it gives you better outcome. But that is kind of silly word. They do not accept the fact that the first argument was not really rational. Rational is an adjective applied to that particular argument, which given before this one, and somehow it was called rational by one person, and then everybody else either was told this or they were taught it when they were undergraduates, and then they just took it as true. Okay. Okay, very good. So, that is the paradox, and that is the resolution of the paradox, and you should appreciate the point that the word rational can be used in some unconvincing way. Okay.
But if the 2 of us know that both of us are rational,
yeah,
then it comes that I will think that the guy is going to accept. So, I should defect, and the other guy will again think.
No, very good. So, you can argue about this. So, this problem of course has been known for a long time, and even this paradox or whatever has been appreciated by large number of people. So, they actually once got some 100 people, experts in game theory, to sit together, and they asked them, what would you do in this problem? And they all knew all this argument I have given here. and 70% of them say I feel safe in defecting. Okay. So, the answer is not clear, but actually I am not so sure about this. I am actually sure that, sorry. So, I am actually sure that this point I should have put in red, and that is quite clear to me, that if the person is truly rational, they should realize that they should stay silent. It is not a deep point, but if you give me some very complicated argument to say that no, 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 your answer should have been that, I listen to you, but I am not convinced. Okay. Okay, very good. So, let us go on to the next one. This is called the minority game. I think in the morning Shushmita called it the congestion game, but this is a particular variation of the general category. So, there are the rest problem is defined like this. With Shashi Devan we did some work on this problem, and later Sitabra also did it. But anyway, there are m plus 1 number of residents in a city. There are 2 restaurants. Each day each resident chooses a restaurant without consulting other residents. They eat out, and so they have to eat, and other things are equal. The food quality is the same, prices are the same. So, the only consideration is to avoid the more crowded restaurant, that is the rule. So, by definition, if they go to a restaurant in which there are too many people, then they feel unhappy and the payoff is 0. If they go to a less crowded restaurant, the payoff is 1. So, in the previous morning's thing, there are 2 roads to go. You want to go to the less crowded road. Okay. So, payoff is 1 if you are in the less crowded restaurant. So, what the only information available to the agents is the history of attendances in early, they in the old, they have old records that on Monday so many people went to restaurant A, on Tuesday so many people went to restaurant A, and so on. They keep on, they have the old record, and then you have to decide what you want to do today. You can say that look, in the past 30% of the people went to restaurant A, so it is the less crowded one, so I will go there. But unfortunately, every other person will decide the same thing, and they will all end up in the same restaurant. Okay, so it is not working. Such trivial strategies do not work in this simple game. So, the question was, what is a good strategy? What will good real rational people, not just arbitrary people who make up some rule and call it rational, will do, and that is the question. And this has been studied as a model of learning, adaptation, self organization, co-evolution. All of these are deep words, and each of them requires long time of study, and they have different facets, but at least some parts of that can be seen here. So, if you have an old record and based on that you are doing something, that is called learning. Or you look at your own past performance and you say, oh, I use this rule that if last time A was crowded, then I go to B and see if it works or does not work, and if it does not work, then I change the rule, that kind of stuff. Adaptation is the same thing, based on the previous learning you change your behavior, and self organization was that people found that if you take the agents to be somewhat reasonable and optimizing in some way, in the end they find the best way in practice, and so that is self organization. And co-evolution, of course, is the whole thing evolves because the people's strategies change, and then the rules which they use can also change. Okay. So, now we come to sort of one particular problem in this minority game which identifies the paradox. So, we consider a variation of the standard minority game in which all agents are rational and selfish. These are the words which we have kind of explained a little bit, and they try to maximize the expected discounted personal payoff. Expected payoff because we are saying that you have a expected winning at nth day, and very far in the future if I win something I give it less weight. So, there is an exponential weight, and that is the total payoff, expected payoff, and discounted by this factor lambda. And so, they want to maximize this, not just tomorrow's payoff, but expected payoff. If lambda is close to 1, this is sort of very long term payoff. If lambda is close to 0, it is short term payoff. If an agent is in a state where his restaurant is m plus r, then today he chooses a number fr between 0 and 1, and then chooses a random number generator and changes his restaurant if this number comes out less than fr. So, with probability fr he changes his restaurant, does not change it with a deterministic algorithm, it is a stochastic algorithm, mixed algorithm. And the strategy consists of choosing the correct set of fr to maximize the expected gain. So, that is what we are trying to do. Once we have selected these fr, then we do not have to change them, because the game is stochastic, it will keep on changing, but my strategy fr will not change with time.
What is capital M?
Sorry?
Capital M.
Capital M is an integer number and it can be any integer positive. So, 3, 10, 15, and the number of it, so I gave it earlier, the number of people is 2m plus 1, odd number, because we want to be clear that there is one majority and one minority, there is no tie. Okay. Okay, so what is this set fr? This is what we want to determine. So, the agents consult an expert in game theory from a reputed business school to find the best possible fr. In general, we expect fr to be an increasing function of r, like if you are in a very big majority, then you want to shift with a bigger probability or larger fraction should shift. So, if r is less than 0, if you are in a minority restaurant, there is a strategy which is called win, stay, lose, shift. It says stay put and so to fr to 0, do not move. It can be shown that this is actually pretty good. Right now, we will not give a rigorous proof, we are just going along. So, people who are in the minority restaurant, they do not move. What about people in the majority? If r is equal to 1, so there is a split m plus 1. So, the advice is to stay put, do not move. Point is, if you move, you will go to this other one, those people are not moving, you will be in m plus 1, you will not win. But if somebody else in your group moves, then you will be in the minority, you will win. So, you will take a luck and maybe you will, maybe you won't. In the other case, you won't do, because the people in the minority restaurant are not moving. So, it turns out that all these people in this minority restaurant went to the same expert, consulted him, and of course, he gave the same advice to everybody, set your fr to 0. And so, everybody set the fr to 0, and they are in the same place, nobody moves, and the situation repeats again, and the next day actually the same advice is given by this expert, who is an expert in game theory. He is advising people how to change, and he is telling them do not do anything. I think that is very stupid. So, the loser today will lose on all the following days, if they follow the advice, right. So, this is clearly the worst possible strategy and the advice is stupid, that is my comment. Okay. This advice is justified in game theory using complicated arguments similar to the prisoner dilemma argument. I gave the argument, it says that if you move you will not do anything better, so stay put, right. The state m plus 1, all agents not moving, is a Nash equilibrium, and any single agent cannot do better by moving differently. Okay. This is not a controversial statement, this is just correct. Okay. The resolution is simple, fire the consultant. It is also not very deep and profound, I am making an obvious point actually. Okay. So, in formal terms, one has to look for a different solution concept which is different from the Nash equilibrium. Nash equilibrium gives you sometimes very stupid answers. So, you have to go beyond Nash equilibrium. Okay. So, the fact is that Nash equilibrium need not be unique and is or optimal is well known, and is, for example, in prisoner dilemma the Nash equilibrium is both people defect and it is not the optimal solution. Okay. It is just the Nash solution. Okay. Nash solution should be distinguished from optimal solution, because there could be many Nash equilibria. The key point to realize is that all agents are going to decide, other agent strategies are not yet frozen, and this point should be kept in mind, and this can change the answer. Okay. So, we proposed in this paper 2014 an alternate solution concept called co-action equilibrium. In this meta strategy is the strategy to decide strategies. Okay. So, the agents realize that all rational agents in the majority group in the split are in the same boat, okay, and they will choose the same value of f0 if r is 0. Now, you put in this that if I choose some value of f, other person will also choose the same value of f, only this much, and then put in all this other algebra and calculate the expected payoff and see what is the value of f0 which maximizes my payoff. The answer is not 0, it is a non-zero value. Okay, so, it gets you out of this paradox or dead end, and this can be seen to avoid the trapping states, and the optimal state f0 is bigger than 0. Okay. So, now let me discuss one third case which is called Samaritan's curse, K. Basu, which is comparatively new. This game was designed to illustrate the point that sometimes it may happen that an agent wants to help a third party, he is a good Samaritan. Samaritan are people who help others and takes action for this. Another agent also thinks similarly and acts similarly. Individually their actions will result in a favorable outcome, but both agents acting together but without consulting each other could end up choosing an action that leaves the third party worse than if the person they were trying to help. So, you are trying to help a person, this person is also trying to help, and actually that person trying to be helped is becoming worse. That is a paradox. Why should it happen? Okay. So, this game was designed by this Kaushik Basu, an erstwhile economic advisor to Manmohan Singh. So, this is exactly the stuff. So, there are two or more industrialists, each of them is trying to set up some factory or something, and so they have a choice action A and B, and these are their payoffs. Okay. So, you know there is some payoff matrix, and they do the standard Nash equilibrium, they select this action BB, and what they do affects other weaker sections of population in the same city, the workers or something, and their payoff matrix is this. So, these bystanders, people who are just standing by, they are not part of the decision making, but they are affected by the outcome. So, their payoffs are these numbers 2804. Okay. So, since this does not enter in this decision making, these guys do not care about what happens to outsider, I maximize my payoff, and that is the best strategy according to Nash equilibrium, they pick it. Okay. But then what happened was that there was some socially conscious person, and he took these people into a weekend seminary school and gave them lot of discussion and told them you should not be so selfish, you should take care of, think about the other people, and they said okay, they were convinced of this point. Okay. So, they said I will not maximize my payoff, I will maximize my payoff plus bystanders payoff. Okay. And both of them do this. So, they end up with a new payoff matrix like this, and then they do the Nash analysis and they pick action AA, but if they pick action AA, this person is at 2, while if they pick this one is at 4. So, the bystander is worse off with this new Samaritan strategy than with the old one. And so, this game, of course, the payoff matrix is arbitrarily rigged up to show this point, but it can happen in some situation, and Kaushik was only trying to indicate that sometimes you have good intentions, but things do not work out according to the way you want it. It happens often in politics, people have good intentions, but they end up doing bad things. Okay. And this is supposed to, it is not in all situations, but in some such situations some such thing could happen. So, this is the explanation. Okay. So, these people, so this is just writing the same thing which I already said. They go to a consciousness raising meeting and they have this stuff, and this guy is worse than before. Okay. So, what is this paradox? You are trying to do better and you are end up doing worse. Okay. So, the resolution of this paradox is that while their intentions were good, the way they went about their intentions was not so wise, it was actually stupid. If you are trying to help that person, you do not maximize your gain plus that guy's gain and then take the Nash equilibrium corresponding to that. That was the slip in the argument. But actually that part, the second part, take some matrix and then maximize the Nash equilibrium is taken as a automatic after, I do not even know all this stuff. I consult my consultant and he tells me the game theorists have told me that this is the best option, and then I go ahead with that. Okay. And I am trying to emphasize here is that maybe one should not always use.
No, but in the 3 you make a 3 cross 3 void.
No, the third party does not have any actions, he cannot do anything. So, that is why okay, you can worry about this. I can also say that look, what I could do is I can go to this, I do not go to this, I go to this and I say okay, if I want the best of this guy and you also want the best of this guy, let us choose this strategy, because we lose a little bit 1-1, but he gains 8 or some such thing. The argument that you want to help this person is not bad, but the way to help is not to maximize your payoff matrix plus his payoff matrix or whatever. That is where the slip comes in. But the point I am making is that quite often in game theory, these points are actually taken as automatic. I do not even have to think twice. When I said first they add their matrix and then do the optimization, nobody blinked. They all said okay, okay, let us go ahead and do it. So, that is the point. Okay. So, very good. Okay. So, secondly, it again shows that Nash equilibrium is not necessarily an optimal outcome. What they got was the Nash equilibrium, but who said that was the optimal answer? Okay. I mean, we gave 2 previous well known examples where Nash equilibrium is actually the stupid answer. Okay. And this prisoner's dilemma is known since 1950. I am not the first person to discuss it. The people who discussed it actually did it because precisely they wanted to identify this point, right. But somehow the lessons learnt were mislearnt, I think. Okay. So, let me conclude, because we would like to have a little bit of time for discussion, if any. One should be careful in applying game theory considerations to real world applications, because as I said, in buying a shirt, I do not even know what is the optimization goal. So, how can I apply game theory? This is not to say one should not think logically, but aware that the answers depend on implicit assumptions made in the analysis. You are confusing the word rational thinking with illogical. Opposite of rational as defined here is not irrational. It is rational in this particular way of single person optimization, something which need not be the only way to think. Okay. And one may need to go beyond Nash equilibrium considerations to get a desirable solution. And this is the last remark I want to make, but we can have a short discussion on this. Game theory is not to be treated as an instrument to legitimize greed, by which is meant the following. People have something they want to do and they have some action, they want to justify it in some way, and sometimes they say, oh, I do not know, but mathematical theory of games tells me that this is the solution. No, the theory does not tell you what is the solution. It depends on what you put in as your optimization goal and how you optimize, and you cannot shift the responsibility on game theorists if you are making wrong choices. I think that is the point I want to make, that if you are making choices, you are responsible for the choices, and if they are stupid choices, I pointed out in the prisoner's dilemma, then don't blame game theory for it. Game theory does not tell that you should do this choice. They say if you argue like this, then you should do this choice. Should you argue like this? No, you shouldn't argue like that. No, very good you are laughing, because I think that was the point I wanted to make, that one has to go beyond the standard way of thinking about games and realize what was our real aim and how it got confused with some mega aim or semi aim or non aim. And sometimes, sometimes actually something like this is done. I know what I want, but I give some mumbo jumbo argument to confuse other people that I wanted this. So, the people who give such arguments are not always stupid. They are actually very smart people, but their optimization goals are different from what you would like. They want something and they give some argument or the other to justify that, and I am saying that you should watch out, is that a good argument or is that a good optimization goal or some such thing before you accept such things. And that is where I will leave. And so, this is thank you, and these are the some of the references you might like to see. This one discusses coaction equilibrium in some detail, and this one is a slightly more complicated mathematical stuff, which actually finds that the best solution for a minority game can be what, you know. And these are these Kaushik Basu's papers. There is an earlier one and there is a later version of the same thing. And okay, so let me stop here.
Questions?
Yes.
You could, so you mentioned, I think you used the word hyper rational or super rational.
Yeah,
Super rational for Prisoner's Dilemma. But sometimes people are also, they cooperate because of principles, like moral principles.
Yeah.
So would you say moral principles are just
No,
another way of
very
mimicking?
good. So, even in this this big experiment with game theories, people have argued that no, we should think differently. So, one group said that look, I am a Christian, and in Christian thing the thing to do is not to betray your friend. So, I will do it irrespective of what he does. Okay. So, that is a attitude which you can take, and then you will do something. It may be right, you know, in this case you might like it or you may not like it, but you know, so they are using some organization principle which is not an optimization goal. It is given by God, you have to do this, you follow those orders, then you are okay. We are actually trying to set up a situation in which the person decides what he wants to do, not somebody else tells them what they have to do. This choice may also be dictated by some higher principles, which may be Christianity, may be a higher principle, but you got to identify it, and you know, in different contexts it may do different things, and sometimes it may do very well, sometimes it may do very badly. So, you have to judge it on its merit, and even invoking you know, scriptures of various sorts need not be the final justification, right. That is a somewhat political statement made in this present context, but I will leave it at that.
So, like, if you say like this, then the payoffs will be individually different, right? Like,
Yeah. So, I am saying that sometimes people decide without invoking payoff. Okay. So, you cannot say all those people are foolish. They are making the judgment, they are deciding what they want to do, and they are not invoking payoffs at all. So, what, you know, maybe the theory is just not applicable in those contexts. Okay. But actually I was talking with some student and she said that yeah, you are saying you want to optimize going from here to there and find the shortest path. I have a car, so I do not care if the path is shortest or not, I just go. No, this is an example, but the point is that that person is not optimizing the shortest path. It is a stupid goal as far as she is concerned. She is optimizing something else. What is she optimizing? She is optimizing her brain usage. No, trouble. She does not want to spend too much effort trying to find out what is the best possible solution. So, she does not do that one. But she has an optimization goal which is slightly different. You cannot say she does not have an optimization goal. When you are choosing amongst two options, you decide on the basis of something or the other. It is just good to know what you are trying to optimize. Sometimes people make unconscious choices, they do not know what they are optimizing, they just do something and then they regret for the rest of their lives, right. Sometimes it happens in marriages. No. See, at that time you made an optimization goal, you decided something and later you are not comfortable with that. Those kinds of things we cannot avoid. But do not blame game theory for this. If you change your optimization goals, the answer which was good answer one time will change into something else later. That is what we were referring to in the morning, because the valuation may change in the process of auction, in the middle of an auction. Where I was saying 500 rupees was my bid, this person says 501, then suddenly I say 600. What happened? I think that I was not good, maybe this thing is worth more than what I thought initially, maybe 600 is a good price. That is the way I think. And in the mathematical theory, you will have to say that the valuation has increased. But I think Sushmita did not allow valuation to change with time. In that setting, the valuation was fixed forever, and then this behavior is very irrational. Okay. But real people are not always fully rational in this sense, that is the point.
This is an experience we all frequently have when we are trying to get an auto rickshaw. So your evaluation says that you should only pay 100 rupees. Auto driver starts with 500. Maybe he won't agree. So my evaluation changed.
No, so these dynamical evaluations are of course implemented in more complicated auctions or so on. So it is not the end of the stuff, but it lets you think that no, I can go beyond this, I can do something else, and that is the purpose of this exercise. Yes, sir.
When you refer to this as Nash equilibrium,
so
how do you define this equilibrium?
Okay, Nash equilibrium is defined earlier in the morning as well, we were not there. He says that there are a lot of agents, each has a strategy. A single agent, by acting by himself, can choose some other strategy, but then he will not do any better. So, if all other strategies are frozen, then this guy is doing the best, and this is true for everybody. Then nobody changes, and this is a sort of state in which nobody wants to change. And so, he called it the equilibrium state. I think that was the word which statistical physicists do not particularly like, because we have a different notion of what we call equilibrium. This is a trapping state. It is a trapping state for single person variation, but two people together may want to together change their decision, then the answer can change. That is what one should realize. That is what happens in the prisoner's dilemma.
But can it be seen as a fixed point of some equation?
Sequence of?
Fixed point of some equation, non-linear equation.
Precisely. So, if you say that there are all these states, from here to here I can go with 1% move, and then from here to there I can go with 2% move. There may be a local minima of something or the other, which is the best solution is with 1% moves, but it is not the best solution with 2 people moves.
Usually non-linear equation may have different fixed points.
Okay, so even in Nash equilibria, a lot of people know this, that you can have several Nash equilibria, and some of them may be much better than others, but anyway.
So the point is that it is difficult to get all the fixed points, or
in the standard game theory analysis, you give me the payoff matrix, with a little bit of computer power, I will list all the Nash equilibria. I just check each one. Is this a Nash equilibrium or not? Not, delete. Whatever remains is a Nash equilibrium. Since the total number of choices is finite, this is a finite process.
But what Deepak has often pointed out is that one of the big problems when we come to it with our physics background is we tend to think of it as a general potential function which is applicable to all. But each individual actually has a different payoff function. And so the thing is, it's in general not possible to write down a single global energy function, unlike in physical systems.
Yeah, and I think what Susmita said in the morning is that for congestion games there is a single such function which says that there are Nash equilibria in this congestion game. In fact, I pointed out this Nash equilibrium. Nobody moves; it's a Nash equilibrium. But is it a desirable state? No, not for the people who are in the minority restaurant. They are condemned to be the underprivileged forever. Right? Suits some people, doesn't suit everybody. It is not an egalitarian solution. Now, if you want egalitarian solution to be the best principle, governing principle which to decide, then you will not choose a Nash equilibrium. Okay. So, deciding what should be your choice to optimize is your choice, and it occurs before all the detailed analysis of the game occurs.
Maybe it's a stupid question, but doesn't the knowledge of the payoff matrix change the matrix itself? Or like, if you know that the payoff has to be like this?
No, so you have to know the entries in the matrix.
Once you know that,
Yeah.
both agents know that,
Huh.
then can they use that knowledge to change the matrix in such a way that they can?
No, so that changes the game. So, right now the setting of the game where the payoff matrix is fixed, you have to decide your strategy. Where do you want to be? Okay. So, that is the setting. If you change the rules of the game and chess becomes bridge, then I do not know what happens. Okay. It is a totally different question.
So, probably at the heart of this lies in the fact that more numbers, right? And that comes up with that preferences are transitive because it is associative. So, myself and another friend here were really trying to work out a game in which we would write out, use other structures apart from numbers, which are inherently non-transitive, and maybe that could give us a better idea. I'm just trying to ask if there are examples where there are non-transitive payoffs.
Okay, no, so transitivity is something like if I prefer A to B and I prefer B to C, then I prefer A to C. If you violate this rule, then what will you like? I mean, then you like I can argue differently and I can this is the best choice. There is no notion of best choice anymore. Okay, that I will say that it is hard to develop a theory for that situation, whatever. If you do not have any notion of what is better than what, and it is not a transitivity relation is not satisfied, then it will be very hard to have a logical structure which allows you to think properly. So, I would not go against transitivity. What people say is, okay, there are things called fuzzy variable theories, in which you say there is three categories: A is better than B, A is less than B, A is nearly the same as B. In which case I do not know if it is better or not. Just one second. So, if you say B is better, is nearly the same as C, C is nearly the same as D, D is nearly the same as E, but A is clearly better than E, you know, that kind of stuff. That structure allows for this, not contradictory, it allows for some structure, but it has not been actually used too much, or it is not very powerful. So, it does not give you many new results. But one can try, you know, the fact that in the past nobody got nice interesting results, Nobel Prize with fuzzy set theory, does not mean that the next one cannot come in that area. Yes, sir.
So, like it's commonly said in many lectures in game theory, that people are like the agents are not rational. So, like
Not fully rational.
Yeah. So, I mean, also like you said, like so. I don't see why we say that they are not right. Like they might be rational according to like the problem is you don't know their payoff matrix.
No, so I am saying that I will allow the word they are rational, not fully rational. Fully rational means they also know how to solve cubic equations or some such thing. They have full information, everything. Okay. So the other part is called bounded rationality, means they are not irrational, but their rationality has some limits.
So the limits are based on information, right?
Yeah, okay, sure. Your information, for example.
for example, like you said in the prisoner's dilemma, someone said it's like that they are a Christian and they have to
Yeah.
they have to cooperate.
Hmm.
So in that case, they would have a different way of matrix, and because like for them, their adherence to the religion.
No, so that is what I referred to, saying that there is a payoff matrix which is in terms of how many years you have to spend in prison. But there is a utility matrix which is not the payoff matrix, but it is a function, monotonic function of the payoff matrix.
Like, so like for them, the payoff might be different.
Of course. No, so I am saying you do not maximize the payoff, you maximize the utility, and these are different things. So you recognize this point.
So what does it mean when we say that someone is acting irrationally? What does that mean?
Acting irrationally
In a game, or
in a game, you know, there is this king and this other guy, and you could have won in one move, and you don't do that, you put it there. I will say that is not a rational choice.
I mean, that is a mistake of skill, right?
No, okay, so you can call it mistake of skill, but the final choice was not a good choice. That's all I can see. When I play chess with a 5-year-old child, they make these mistakes, and we teach them how to play properly, you know, that is what it is called. Okay, so you will not glorify the fact that 5-year-old cannot play chess well, right? So I am not glorifying it. Okay, people make wrong choices, but they could have made a better choice. That is what we are trying to discuss. Okay, but that choice has to be consistent with what they think and what they believe and all that kind of stuff. And yeah, in the real world, there are these standoffs where people believe in different things and they keep on fighting, and you cannot avoid it. Game theory cannot help, right?
No, but I think in that case you could have, I guess you were alluding to the World Chess Championship match.
I wasn't, but okay.
You could argue that he was so tired by that time that he simply didn't
Yeah, okay, so he made a stupid move. Everybody would agree that he.
Rational, I guess he's saying that where you deliberately choose something which is not rational. Is that?
I mean, like in that case, I think he did not even bother to make a way of metrics and think about it.
But they say what is a good move. This is what you have to decide in chess.
In that case, I think he did not bother to think about
No,
it.
so he got tired. Let us say, your argument is that he got tired and he didn't choose correctly. We are agreeing with that, but the point is we are not discussing what individuals do. We are saying what they should have or could have done, right? So I am not going to put him in jail for the choice he made. No, that's a crime, you know, something. But if he deliberately did it to lose, you know, maybe you can be put in jail. So that's a different question. We are not discussing that question. We are only saying was that a good choice or a bad choice. Okay. Okay.
Well, if there are no further questions, let's thank you.